This video is going to look at limiting reactant calculations. Before you start limiting reactant calculations, it's important that you have a good grasp of your mole calculations and specifically how you calculate the mass of reactant or mass of product from a moles equation. Here's an exam style question on limiting reactants. Calcium chloride is added to tinned vegetables as a firming agent to keep the food from becoming too soft. A manufacturer produced calcium chloride by reacting 42 grams of calcium oxide with 36.5 grams of hydrochloric acid. Decide which element is the limiting agent and hence the maximum mass of calcium chloride which can be produced by this reaction. So the main difference between limiting reactant calculations and any other type of moles calculation is that you're given two different masses in your question. So we're told we have 42 grams of calcium oxide and we have 36.5 grams of hydrochloric acid. As with our moles calculations, our first step is always to convert the mass given into moles. But because in these examples we have two masses, we have to convert both masses into moles. So let's look at the calcium oxide to start with. So our calcium oxide, CaO, we have to work out our MR of that. So our MR, we have 1 calcium and 1 oxygen. So in this case, my mass of calcium for my periodic table is 40. The mass of my oxygen is 16. So my MR is 56. My next step then is to convert my mass, which was given, into moles. So the mass that I was given was 42 grams. So I'm going to say my moles is equal to my mass over my MR. So that's going to be my 42 divided by 56, which is equal to 0.75 moles. I have to do the same thing for my other mass. So this time I'm going to be looking at my HCl. I'm told, first I have to work out my MR. So my MR this time is going to be 1 hydrogen and 1 chlorine. Now, the important thing is whenever we're working out MRs, remember not to take account of this big 2. Okay, so this 2 is our balancing figure. We'll use it in our ratio and we'll also use it whenever we're working out our limiting agent, but we only ever work out our MR for 1 mole of the substance. So that's why it's 1 hydrogen and 1 chlorine. So the mass in the periodic table of our hydrogen is 1, so it's 1 times 1, plus 1 chlorine, which is 35.5. So adding that all together gets my MR of 36.5. Same as before, moles is equal to my mass over my MR. So it's going to be 36.5, which is my mass from my equation, divided by 36.5, which is my MR. So it's equal to 1 mole. The next thing I have to do then is to calculate my limiting agent. Now, this is a new step. This isn't something that is done in any other type of mole calculations. What I'd strongly suggest you do in this is put it in a separate wee box. The reason for this is we only do this step to calculate our limiting agent. We don't use it for anything else. So to do this very simple step, all we need to do is we take our moles of each reactant and we divide it by the balancing number. So for my calcium oxide, I know I have 0.75 moles. And my balancing number for it is 1. Okay, so my balancing number is just whatever number is before it in the equation. So in this case, that is going to be 0.75, a nice and easy calculation. I do the same thing for my HCl. In my HCl I have 1 mole, but my balancing figure in this case is 2. So because my balancing figure is 2, I'm going to divide 1 by 2, which is equal to 0.5. Now, the number which is smallest at this point is my limiting reactant. So that means that because my HCl is my smaller number, that is my limiting agent, whereas my calcium oxide, because it's the bigger number, we would say it is an excess. In other words, we have too much calcium oxide for the amount of HCl. Now, the reason why we do that is because we have to actually take into account the ratio from the equation when we calculate our limiting agent. Everything else from here on then must focus on the limiting agent to carry through to the mass of calcium chloride which can be produced. So that brings me on to our third step. So we have to use the ratio to calculate the mass of product which we have. So because we know that our HCl is our limiting agent, that essentially means we can ignore everything else in this equation apart from my limiting agent, which is my hydrochloric acid, and the calcium chloride, which is the mass I'm trying to figure out. So just as you would have done whenever you were doing your normal mole calculations, you would have looked at the ratio between the number of moles. So in my question, I had been told that I had 36.5 grams of hydrochloric acid, and I've already worked out that that is 1 mole. Now, that's why I suggest you do step 2 in a separate box, because you do not use this 0.5. It is important that you use the moles of product that you worked out in the first step. Now, from my equation, I can look at my ratio between my HCl going to my calcium chloride. So I would say that my ratio here is a 2:1 ratio from my equation. I know that I actually have 1 mole of hydrochloric acid. So I would say 1 mole would give me 0.5 moles of my calcium chloride. That brings us to our final step, step 4, which is to calculate the mass of product. So I know that I'm trying to work out calcium chloride here. So I must work out my MR. So in calcium chloride, I have 1 calcium and I have 2 chlorines. So that's going to be 1 times 40 plus 2 times 35.5, which is going to be equal to 111. I then can work out my mass by saying my mass is equal to my moles times my MR. I know that my moles from the previous part was 0.5, the maximum number of moles I can produce is 0.5 moles. So it's 0.5 times 111, which is going to equal to 55.5 grams, and that is my final answer.